This video is about similar shapes. These two shapes are similar. They are similar because they have the same angles, 30, 30, 52, 52, 98, 98. So the angles are exactly the same, which means that all of the sides are in proportion. Whenever we have a shape where all of the angles are the same, that must mean the sides are in proportion. And vice versa, if all of the sides are in proportion, that must mean that all the angles are the same. So whenever you see the word similar in a mathematical setting, it means these two things. So we can see here all the angles are the same, and if we look at the sides, I can see that all of the sides here are 1.5 times bigger than all of the sides over here. And I could work that out in a number of different ways. I could do 6 divided by 4, or I could just look at the 5 and the 7.5 and say, well, 5 times 1.5 gives 7.5. Or I could do 3.75 divided by 2.5, or I could do 7.5 divided by 5. So basically I could work out the scale factor by dividing these, whatever combination I have. So let's have a look at an example. I am told that these two shapes are similar, and therefore I know that their sides are in proportion. So I can work out the scale factor. I can see that this side AB and this side here EF, they are the same, or at least I can work out what the scale factor is between them. So if I do 10.5 divided by 4.2, that will tell me what my scale factor is. And if I do that, I get 2.5. So therefore, cover that up. So that is my scale factor. This shape here, each length in this shape here is 2.5 times bigger than each of the sides here. This is 2.5 times bigger than this. Therefore, if I wanted to work out the length CD here, all I need to do is look over here. I can see that's 9.25, and I know that this is 2.5 times smaller. So if I do 9.25 divided by 2.5, I work out that CD is 3.7 meters long. Similarly, if I want to work out ED, I can look over here and see that this is 6.4. I know that this is 2.5 times bigger, so 6.4 times 2.5 is 16. Second example. We could be given something like this. Now, to begin with, it might look like we've only been given one triangle, but in fact there are two triangles here. They are hidden, and they are two similar triangles. What I'm going to do is I'm going to draw these two triangles separately. I'm going to draw this small triangle. Yeah. So this is this triangle here, 5 and x. And I don't know what this over here is. 5 and x, and I don't know what this over here is. And then I have the bigger triangle where the whole thing here is 15, the whole thing here is 12, and all of this here, I don't know what that is. So 15 and 12. I know that these shapes are going to be similar because I know they have the same angle. I know that this is the same angle as this angle, and I know that this angle is the same angle as this angle, and finally I know that this angle is the same as this angle. So these shapes are similar. So all I need to do is work out the scale factor. So 15 divided by 5 is 3. So I can see the scale factor is 3. So therefore the bigger shape is 3 times bigger than the smaller shape. So if that's 12, that's got to be 4. And that's it.